right, so the first thing that we're doing is an exploration. We are graphing x plus 4 squared. Then we're going to look at our graph, and I'm going to ask you, where is the x-intercept? Well, the x-intercept is at -4. I'm just kind of sketching it right there, but you know, when we solve for x-intercepts, we put 0 in for y, and then we solve each factor for x, just like we did in our assignment quite a few times. So we solve this for x, and we get x equals -4. So before I type in the next one, where's my x-intercept going to be for the next one? It's also a -4. What's my graph going to, where's the x-intercept for the third one? It's also going to be -4. So how are these going to be different? Okay, so I should have done this, and I didn't even think about doing this. Let's go back, and let's take out the squared part. Let's just make it x plus 4. Oops. So if you hit delete on top of that squared, it'll get rid of just the square. You don't have to retype it. You hit the DEL button, the delete button. You know what? The same conversation happened yesterday. There's also an insert button, which I'll show you. And that saves me a lot of time. And I had the same conversation with my class yesterday. They were like, I didn't even know that existed. Okay, so when I type in just x plus 4 and I hit graph, where's my x-intercept? Yeah, it's linear, and it crosses through at -4, and then when we change it to quadratic, back to quadratic, it now bounces off -4. And it looks like a parabola right at -4. So now let's change it to cubic. Let's go back to y equals, and let's change that little 2 up there. Go sit right on top of the 2. It's your cursor, so it's right on top of the 2, and just hit 3, so you don't have to retype the whole thing. Once you graph that, you should see that the graph still is crossing through -4, but this time it has this little cubic shape right at -4. And it's odd, so the end behavior is odd behavior. And then we go change it to 4th power. Go change it to 4th power. Go y equals, and put your cursor on top of the 3, and just hit 4 so you don't have to retype everything in. You can look at any of them that you want to. Can we kind of make a conclusion or maybe a hypothesis of how you know what the shape is going to be? What do you think?
Stevens are
Stevens, I'm not going to call them all parabolas because just the quadratic is a parabola, but they all have that same kind of U shape. It's just like the bottom gets wider. So all evens have this same end behavior. And then what do odds do? There's the odd behavior, the odd end behavior. So now what I'm doing is we're going to go back to the notes. And I've got a new column, and we're going to do it one at a time. We're not going to do all of them on top of each other because it's too confusing. Let's just type in y1 as x parenthesis x minus 5. Do you know what the x-intercepts are going to be before we type it in? 5 and? 0. The x-intercepts are going to be at 0 and 5 because you have to set each factor equal to a 0 and solve each factor. So we're going to have x-intercepts at 0 and 5. Go ahead and graph it. You'll like it once I explain it. Okay. So the overall shape is a parabola. Because if I were to distribute the equation, if I were to distribute that x back in, I would get x squared minus 5x, and then my degree would be 2. So my overall shape is a parabola. But at the x-intercepts, it just goes straight through. At the x-intercepts, it goes straight through. And that's because how many x's am I solving for here? X to the first, which is linear. And this one over here is x minus 5, but it's x to the first, which is linear. So at each x-intercept, it passes through the x-axis just like a line would. So now what I've done for the second one is we're going to change it so the x is still x to the first, but our x minus 5 is going to be squared. So that should not change our x-intercepts. It's just going to change the behavior at the x-intercepts. Go ahead and graph that one. Now, I'm going to change my window just so you can see it a little bit better what's happening, especially if you have a not a color one, a little bit easier to see. So I'm changing, you don't have to change your window, but I'm going to. That didn't help very much. All right. Now we're talking about x-intercepts. That's all we're talking about right now. And at the x-intercept, which is 0, there's only one x. There's only x the first here, and it just passes through like a line would. But what happens when I make x minus 5 twice squared? What does it do at that 5? It bounces off. If I were to cover up the rest of the graph, what does that kind of look like right at the 5? Looks like a square. It looks like a parabola right at that 5. So the behavior at the x-intercept has to do with what the exponent is for that x-intercept. Let's see that. Let's change it. Let's go change it to a third. Let's go change it to a third. So you just go on top of the 2 and change it into a 30. That's the fastest way of doing it. I'm going to have to change my graph a little bit for this one. Let's see if it zooms a bit where it's a little. So I just zoomed this to a different window, but you can still look at the x-intercepts. So at x equals 0, it's passing through just like a line. But at x equals 5, it now looks like a cubic because x minus 5 was to the third power. Let's look at the overall end behavior of the entire graph. Both sides are up. Why is that? Because if I were to multiply this all out, I would have an x cubed multiplied by an x. So I would have x to the fourth as my degree. And because it's positive up front. If I were to multiply it all out. So it's an even overall. And then separately, these are odds. So let's go and let's go y equals. And we're going to change it. And you're going to have to do the insert button now. This one's not on our paper. We're just making this one up. I'm going to change this so it is already what we're changing it to. X squared parenthesis x minus 5 squared. We're changing it to that. So in order to use the insert button, you go like on top of the parenthesis, and you do second DEL, which is right above its INS. And then you can hit squared, and it pops it in, so you don't have to retype everything. I love the insert button. And then for the third, I'm going to change it into squared. What happens when you graph it?
I don't know what happened to mine. Oh, I shouldn't have -5. I should have -5. What happened there? Oh, I didn't add up at 100. There we go. You're kind of like a, you can't see the whole thing, but it's a W shape. Oh, that doesn't even show it at all. What is happening at the x-intercept that is at 0? The x-intercept at 0, what's happening at it? Like, it looks like a little parabola there. It comes down and bounces right back off. And then what happens with the x-intercept of 5? It looks like we've got two parabolas because each of these is now squared. So this is what I'm talking about when I say multiplicity, which we're going to say a few times today. Multiplicity means how many x-intercepts occur at 0. And you'd say, oh, that x-intercept 0, that has a multiplicity of 2, because there's 2 of those factors that are x equals 0. And what is the multiplicity of x minus 5 equals 0 or x equals 5? What's the multiplicity of this one? What's the x one? 2. Okay, 2. Over here on y3, before we typed in our own thing, what's the multiplicity of x minus 5 to the third? What's the multiplicity of it? 3. What's the multiplicity of just x? 1. So if I were to write those factors all the way out, like this one right here, if I were to write those factors all the way out, it would look like x, x minus 5, x minus 5, x minus 5. So my x-intercepts, I would have 1 at 0, and I would have 1 at 5 with a multiplicity of 3. Am I on the screen? Kind of. And then what does that multiplicity do to the graph? When I had just x minus 5, or when I had x minus 5 squared, or I had x minus 5 cubed, what does that do to the graph? It doesn't change the x-intercepts. What does it do? Kind of. What does the squared do at the x-intercept? You guys saw this happen, right? What was happening? What's different? If it's just like x minus 5, or if it's x minus 5 squared? You need to do it again. If I told you to just, you can use this space, by the way. If I told you to just graph y equals x plus 3, it'll be a line, and where would it pass through the x-axis? If I made y 0, it would pass through at -3. That'd be a line, passes through at -3. But if I made it y equals x plus 3 squared, my x-intercept is still -3, but what is happening now? At -3. It bounces. So for squared, what's the end behavior of the whole graph? Even? And so if it starts up and it comes down, it's going to bounce at 3, and then it's going to go back up again. It's going to look like a parabola at 3, or -3. This is what we're doing today. Partially what we're doing today. Okay, if you go now back to the front page. My notes are so organized today. We're going to look at example 1. We're going to do this together. It says solve this equation by factoring, which is what we've been doing the past few days. We've gone over factoring a few times. How do you solve by factoring? What's our first step? GCF. Is there a GCF? Yeah. What is it? No. 2x. So we're going to factor out that GCF. Factored out that GCF, then what do we do? Is it factored all the way? What do we do then? Guess and check. Because we have a trinomial, we're going to guess and check with that trinomial. So I'm going to have two parentheses. X and x. This sign is plus. That means that both signs are the same. This one over here is minus, so they've got to both be minuses. We'll multiply together to give us positive 9, but adds to give us negative 6. And you could FOIL it back together to check. Since they are the same, I'm going to write them squared. Once I have it factored, what am I going to solve? Set every factor equal to 0. So my first factor is 2x. My next factor is x minus 3. And I have another factor, but it's also x minus 3. So I'm going to set each factor equal to 0 and solve each factor. Two of them are exactly the same. This means there is a multiplicity. And when I talk about multiplicity and I write it as a word so that there's not like too many numbers there confusing you what is actually a number and what is how many there are. So I'm writing multiplicity as a word on purpose. So let's read through this. The solutions or the roots or the zeros of this function are, what are the roots or the zeros? 0 and 3. That's where my x-intercepts would be. Now, my first x-intercept at 0 has a multiplicity of, how many zeros did we have when we solved it? 1. O-N-E. And my second one, 3, has a multiplicity of T-W-O. Oh, I'm not on the board. On the screen. Here we go. Here we go. We look at the very original question. What was the degree of the very original question? What was the degree? We forget how to find degree? 3. 3 is the degree. And the leading coefficient is 2. Because the degree is odd, and the leading coefficient, and this should say is positive, thank you. The end behavior is, and I'm just going to sketch that. I'm going to review end behavior. So we're going to sketch a graph without looking at it first. So I know that we have x-intercepts at 0 and at 3. I know the end behavior. So I know the very ends of it. The left side is going to go down, and the right side is going to go up. Because that's the end behavior. I just have to figure out what goes on in between. And this is not going to be 100% accurate. This is just an estimation. So I have to use my multiplicity. Because there's a multiplicity at 0 of just 1, it only occurs once, I know that's going to go through like a line. And at 3, there's a multiplicity of 2. So I know it's going to look like a little parabola at 3. And all I have to do from there is connect these. And I have to kind of use what I know about graphs, and you'll see it over and over again when we check it on the calculator. It's just going to curve around to connect. It will not be a sharp edge. It will not be a sharp edge. It'll be a nice curve when they connect. Okay, and then let's go ahead and type it in our graphing calculator and check and type in please the original equation. Don't type in the factored one. Type in the original equation and let's see how good we do. Let's see how accurate we graphed it. I think that's pretty good. Following? You may have issues with your calculator when you type it in yourself. Obviously. Okay, so every time we have an even multiplicity, at that x-intercept. Doesn't matter if it's 2 or 4 or 6. Anytime we have an even multiplicity at that x-intercept, what's going to happen at that x-intercept? If it's even. Huh? It's going to be kind of parabola shaped. It's basically going to bounce off. It could also be the other way. It could be an upside down one. It's going to bounce. If it's even, it's going to bounce. But if I have an odd multiplicity, at the x-intercept, if I have an odd multiplicity at the x-intercept, it's going to pass through it. Might look different when it's passing through it, but it's going to pass through it. If it's odd, it's going to bounce and go the other way if it's even. Every time. No exceptions. When you are ready to go on, turn the page in your note. We're going to do another example. We're going to do it from scratch, and then we will check it on our calculator lab. You turn your calculator off for now, save some batteries. And if you are really tired and you want to stand up on that counter or stand up on one of those back seats, feel free. So this one says find the zeros. How do I do the equation if I'm finding the zeros? Get rid of f of x and make it 0 equals negative 2x to the 4th plus 16x squared minus 32. So we're going to find the zeros and we're going to sketch the function. We're going to do this by factoring because that's all we've learned so far. So is there a GCF? What is it?